In this video, we're going to solve another circuit with node voltage method, and this circuit also involves a supernode just like the previous lecture circuit did. So let's take a look at this circuit. You can see here is the supernode, this 6-volt source. Again, a supernode is when neither side of the voltage source is connected to ground. Here's a known node because this voltage source, one side is connected to ground. So that's a known. Then we have another unknown node here where a current source and two resistors connect. So as mentioned in the previous video, when you have a supernode, for the purposes of writing a Kcl equation, you just treat that supernode as one node. Okay. Then when we write the currents in terms of voltage, we then go back to treating the nodes of the supernode as two nodes. Okay, so let's write the Kcl equations. Now, one thing I wanted to point out in this circuit is sometimes in drawings you'll see two ground symbols like you see here, but that's all the same ground. Sometimes it's just shown like this for convenience, but don't think this is, you know, some other sort of ground or something like that. It's the same ground here that's defined to be 0 volts. So let's start with the Kcl at the supernode. Okay, so at supernode. So looking right here, see we've got I1 flowing in, and we have I2 flowing into the supernode. That's up here. And then that's going to equal the 2 amps that's flowing out of the supernode. Okay, so we account for all the currents in and out of the supernode. Okay, then we have Kcl at the other node here, C. And at this node we have 2 amps flowing in, and we've got I3 plus I4 flowing out. Okay, now we write our currents in terms of voltage using Ohm's law. So starting with I1, now notice I1 is going up like this from ground to node A. So I1 is going to be 0 minus VA, because you always start with the voltage on the higher voltage end through the resistor, right? The current goes through the resistor from the higher voltage end to the lower, so we start at the higher voltage end, which is ground, so it's 0 minus the voltage VA. Then that's divided by 1. Then you have I2, which is going to be 5 minus VB divided by 10, and that equals 2. Oops. Try that again. Okay, so that equals 2. Then down here we'll have 2 equals I3, which is VC minus 0, right, VC minus ground, over 2, and then I4 would be VC minus 5 over 4. Okay, so those are our node voltage expressions, and just like last time, when we're done writing our node voltage expressions from our Kcl equations, well, we're equation short, right? Because we've got 3 unknowns, VA, VB, and VC, but 2 node voltage expressions. So this is where looking at the voltage source, that's the supernode, comes into play. That when you have a voltage source where when you have a voltage source, the value of the voltage source tells you the difference of the voltages at the nodes that it's connected to. So there's 6 volts across nodes A and B, and the polarity here, all right, where the higher end side is to node B, this tells me that the voltage at node B is 6 volts higher than the voltage at node A. So my third equation is just going to be VB minus VC, oops, VC is equal to 6. Okay, so, oops, that's a mistake. I'm sorry, it's not VC. Let's do that over again. Ignore that there. It's going to be VB minus VA. Sorry about that. Okay, equal to 6. Okay, there we go. That's correct. So now we've got our 3 equations, 3 unknowns. You can go ahead and solve. And let's see. When I solved, I got that VA. We'll write it over here. VA comes out to negative 1.9 volts. Okay, 1.9 volts, or minus 1.9 volts for VA. VB is just going to be 6 more than that. Right, so that's going to be 4.1 volts. And then VC comes out to 4 1/3 volts. Alright, so you want to make sure that you work through the solving the simultaneous equations and you can get these same answers. And then, like always, once you have these node voltage answers, you should be able to go back to the circuit and obtain any current and any voltage for an element, and therefore any power for the element.